Ajay and Ray from 3rd year to B.
Myself Anachan Balaji, 3rd year to B.
Myself Joshua from 3rd year to B.
I will be explaining about single phase full wave rectifier with thyristor family. Okay, so in this circuit, as you can see, it is a part of a full wave rectifier, but we have focused. So as you can see in this circuit, we have used full wave rectifier, but instead of diodes, we have used SCRs, which are thyristor family, and also we will be referring to this Google reference photo. First, let us in this rectifier we will be using AC supply. For any rectifiers we will be using AC supply. So AC supply is a sine waveform. In this, let us assume at initial state this is a positive half cycle and this is a negative half cycle. At initial state, positive will be flowing through in this way and negative will be in this terminal. So this is A and this is B. At 1, 2, 3, 4. At positive half cycle, the thyristor 1 and 3 will be in on state, which will be given by a gate pulse. This is a gate. So by triggering with some control measures, we will be triggering these gate pulses 1 and 3 in order to activate this in order to rectify this positive half cycle. So once this has been positive half cycle has been provided in this way, the gate pulses will be activated on the thyristor 1 and 3, and the current will flow in this way and starts to flow in here, 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 and it will move here because this will be not in on state. So the potential will be in this way. So current flows from here to here and then to negative. So as a result, we will be getting positive half cycle. But when the supply is given, the gate pulse will take off of it. So we can assume it as alpha angle, which will be, let us take as a 45 degree. For 45 degree, the gate pulse will be triggered. So this will be at high state. From this, the rectification will be begun. From here, the rectified waveform will be like this for positive half cycle. And in this, I will be explaining this. And for this state, this will be like this. And for negative half cycle, the position will be like this. Polarity will be changed, which is minus and positive. And for this case, thyristor 1 and 3 will not be active. Instead, the 4 and 2 will be active with some gate pulses, as I said, for these thyristors. So in this circuit, the same angle 45 degree will be measured, and here also they will be like this. From here, the gate trigger will be begun, and this negative half cycle become positive one in a positive side, which because let us say from this the current flows. Okay, from this the current flows from here. Since okay, in consideration of negative half cycle, let us say the positive is here and the negative is here. So in here the current will flow from here. Before that, the thyristor which will be on in this negative half cycle are 4 and 3, keep that in mind, and this will not be considered, this will be in an open circuit. So from when the current flows here, it will not move here, it will be in a closed switch, open switch. So the current flows here and in this way. So as you can see, the positive half cycle also the current flows here, and in also the negative cycle the current flows here. So in case we will not be receiving any load here in this way, so the current always flow in this way. That's why we are getting a positive half cycle in this way, and the current after receiving the load, it will move to the supply in this manner. So as I have said that so this part will be referred as an inversion, whereas this side will be referred as an rectification. You may wonder why there is an inversion part in the full wave rectifier, but since the most of the wave that is covered here is a full wave positive side, so it will be considered as a DC current and as an AC current, which requires an inversion type. So why this occurs is that there is an, as you can see, there is an R load and a L load. So since there is an L load here, there will be a current flowing through here. So which is that when there is, always remember that when there is an R and L load, there will be a continuous conduction, there will be a continuous current conduction, which is that there will be no zero current in the load. So this induction will always ensure that there will be a current flow, but as you can see, when there is a change in polarity, this will be de-energized and re-energized for some time taken. That time taken will be referred as this negative half cycle. Okay, now the same will be for the positive half cycle like this. And just for reference, I am drawing a rough diagram. You need to make sure that your waveform should be clear.
I have one doubt, Ajay. How many diodes should be connected in the single phase full wave rectifier in two pulse?
First of all, this is not a diode, it is a thyristor, and for full wave rectifier you should have more than two. I mean, two arms should be there. Each one arm should have two thyristor for one half cycle and another half cycle. And you may also wonder how many gate pulses we have given here. So most of them thinking that this is a 4 pulse, but at an instant, as you can see in positive half cycle, we are only triggering this and this. So at that instance, there will be only 2 pulses acting in it. So we can also say that it is a 2 pulse rectifier, but in consideration we will be giving 4 pulses to it, which may be in a separate manner or a individual manner. As per the control we are giving, it varies, and I hope you are clear your doubt. And for this is output voltage, and let us consider gate here, gate voltage. So in gate voltage there will be nothing much, which will be just high voltage current, high voltage.